Alrighty, it is November 6th, 2000 and 2022, November 6th. And it is almost an hour to midnight, and I wanted to get like 1 hour streaming before the day ends. Just to make sure I'm streaming. Okay, I am. And we're gonna go ahead and go to TCM Security, and we finish up that last section, which was about tarball, um, stuff like that. I guess users and groups is kind of get important. I use a system with two users, me and sudo account. I guess we're going to learn about that. We haven't talked about that at all yet. Um, just to recap, tarball. Oh yeah, let me start my VM. They're explaining like you can group files together, and you don't have to compress them yet. You could just group them together, and then later on you could decide compression algorithms you want to use and stuff like that. Um, I personally don't have a use for stuff like that yet. Um, Maybe in the future. It's just good to know what's possible and um, how to get help when you need it. Just like the video said. Okay. And one thing I forgot is that was annoying is that a lot of my commands were blocked by the camera. It's supposed to be in this right corner, and I have I noticed it a while ago, and I kept on doing it for the last video. So I'm gonna try to keep it out of that corner. Maybe over here. Okay. Groups.
Linux primarily manages access to resources based on a user's ID and the groups in which they are a member. A user account in Linux is similar to user accounts in other operating systems. Before we dive into the details about users and groups, let's see who is logged onto my system. There are three commands we could use: users, who, and w. They all basically do the same thing. They just have different options and formatting of output. Let's use all three to see the differences. While W provides the most information, who is the more commonly used command. We can see that Bob is the only user currently logged into the system. On Linux servers, you could see many more users listed. Associated with the account is a username, a password, a home directory, and other information. Since Linux uses simple text files for configuration, we can see most of this in the etc password file. Let's look at the information stored in this password file. There are 7 columns separated by a colon. The first column is the username. For example, the first username listed is root. This is the superuser or administrator account on a Linux system. The second column used to be a hash of the user's password. However, people realized that this was very insecure since all users have read access to this file. As a result, The hash was moved to the shadow password
Shadow.
file etc shadow and has restricted access. As a result, an X is placed in this column in the etc password file. Sometimes you may see an asterisk here. This is done to disable logins to the account while still preserving the account information. The third column is the user's unique identifier in the system. The root user's ID is 0. The fourth column is the unique identifier of the user's primary group. Both of these identifiers are used internally in Linux for things like file permissions and process management, both of which we will discuss in later videos. The fifth column is a text field that provides additional information about the account. For example, it can include the user's full name, their office number, or telephone number. Each piece of information is separated by a comma. We can see a few examples here for system accounts and the users Bob and Sally. The sixth column is the user's home directory, which we have already discussed in previous videos. The last column is the user's default shell. Most of the time you will see bin bash for real users of the system.
Okay, what's the other shell? I've never used it. I felt like one's enough.
Note that many of the shells listed here are user bin no login. You may also see bin false. These are used as a security measure to prevent someone from logging onto the system as this user in an interactive shell. As you can see, there are many user accounts for system processes. Linux does this to simplify managing access rights and to minimize chances of privilege escalation if someone were to compromise the accounts. If we scroll to the bottom of the file, we see that the normal user accounts start with user ID 1000. Now, let's look at the group file etc group. This file has 4 columns. The first column is the group name. We see that for most of these groups, the name is the same as the user. This is because these are the primary groups for the users. Every user has a group that is associated with just that user. It is used to simplify management of permissions. The second column is for the group password. This isn't used anymore, so an X is simply placed here. The third column is the group's unique identifier. We saw this number in etc password file when it was used to specify the user's primary group. The last column is a comma-separated list of usernames of users that are members of the group. The default groups aren't too exciting for the most part, but there are 2 groups that are important. The admin group indicates which users can elevate their privileges to administrator level. It is shown here as ADM, but it is also commonly referred to as the wheel group. The second group, sudo, indicates the users that are able to run commands as any user and any group. We will discuss how these are used in another video. In production systems, you will often find customized groups at the end of the file. For example, in a university, you may have a group for a particular set of students in a course. The details depend on the usage of the system. Now that you understand how all the information about users and groups is stored, let's see how they are used in the system. If we do a long listing of the directory home, we see that these directories are owned by specific users and groups. We will discuss how ownership works and its effects on permissions in a later video. There are a number of commands you can use to administer users and groups in Linux. They are beyond the scope of this course, but if you are interested in learning more about them, there are numerous resources on the internet. The wheel group. The second group, sudo, indicates the users that are able to run commands as any user and any group.
So let's just take a look at that file. Ziggy password is in the shadow file, and I am the second user. Callie is the first user, and root is its own thing. I don't think you can even log in as root.
We will discuss how these are used in another video. In production systems, you will often find customized groups at the end of the file. For example, in a university, you may...
What is that sudo? Callie. So Ziggy can't use sudo. Um, okay, I don't remember the command to change user. And that is crazy.
may have a group for a particular set of students in a course. The details depend on the usage of the system. Now that you understand how all the information about users and groups is stored, let's see how they are used in the system. If we do a long listing of the directory home, we see that these directories are owned by specific users and groups. A password, a home. The first column is the username. For example, the first username list access. For example, it can use. The last column is the user in an interactive shell. As you can see, there are many users. Now, let's look at the group file etc group. This file has 4 columns. The first column is the group name. We see that for most of these groups, the name is the same as the user. This is because these are the primary groups for the users. Every user has a group that is associated with just that user. It is used to simplify management of permissions. The second column is for the group. This file has 4 columns. The first column is the group name. We see that for most of these groups, the name is the same as the user. This is because these are the primary groups for the users. Every user has a group that is associated with just that user. It is used to simplify management of permissions. The second column is for the group password. This isn't used anymore, so an X is simply placed here. The third column is the group's unique identifier. We saw this number in Etsy password file when it was used to specify the user's primary group. The last column is a comma-separated list of usernames of users that are members of the group. The default groups aren't too exciting for the most part, but there are two groups that are important. The admin group.
Okay, it's for users. It's driving me crazy, and I can't believe that I forgot the SU. I don't want to look it up. I just want to remember it. Okay, I kind of remembered it. Oh, it works. Okay, I'm not in that file. This incident will be reported. What's this? What's this? What's this right here? Alright, I'm gonna change back to Kelly. Wait, is there a root? There's a default password for Kelly, and it is in VirtualBox information. Huh. Well, we'll probably get there. It's only giving me the Kelly using it.
Linux uses a simple permissions mechanism to ensure proper user access to files and directories. We can see these permissions using ls with a long listing. The permissions are shown in the first column. There are 10 fields shown and are broken into 4 blocks. The first character indicates the type of the item. In the listing here, you can see that directories start with a D, symbolic links start with an L. Normal files don't have an indicating character, so a dash is displayed as a placeholder. Each of the next three blocks are indicated by 3 characters each. The first block of characters is the permissions for the owner of the file or directory. The owner is shown in the third output column. The second permission block,
the group,
is for users of the same group as the one associated with the file. This group is shown in the fourth output column. The final permission block is for all other users and is often referred to as world permissions. For each group, the 3 characters represent read, write, and execute permissions. For example, the file hello.txt is owned by Bob and has a group Bob. As we discussed in a previous video, even though they have the same name, they are different things. In this case, the owner can read and write the file, but can't execute it. This is normal since it is just a text file. The group has the same permissions, but the world only has read access, meaning they can't modify the file. I do want to point out that it may seem odd to execute a directory, but that is actually a very important permission. The execute permission for a directory determines if the user can execute a command in that directory. For example, if you don't have execute permissions for a directory, you can't execute the ls command to see the files in the directory. The only exception to these permissions is that an administrator such as root can access any file on the file system. If you want to change the permissions of a file or directory, use the chmod command. As we can see in the man page, there are 2 ways to specify new permissions. The first is symbolic mode, and the second is octal mode. Let's first look at the symbolic mode first. As we can see here in the man page, we first specify the user, then an operator indicating the type of change, and lastly the permission itself. We can specify the appropriate user U by indicating the owner, G indicating users in the file's group, O indicating other users, or A for everyone. For the operators, we can specify a plus sign for adding permissions, a minus sign for removing permissions, or an equal sign for adding permissions and removing other permissions. The most commonly used permissions are the same read, write, and execute that we saw when we used ls. There are other options, but we can read more about those later. Let's look at an example. First, let's change the permissions on hello.txt by removing group write permissions. We can do that with the following command. Notice that group does not have write permissions anymore. We decide later that we want only the owner to be able to read the file. There are a number of ways to do this, but I'll use the equals operator here as an example. What this command does is it changes the permissions for all users to no permissions, and then adds read permissions for the user or owner of the file. Symbolic mode might seem easier, but in my opinion, remembering all the different characters and combinations can be problematic. Octal mode requires that you know how to count an octal, but once you know how, it becomes very easy to use.
Oh, this is symbolic.
With that in mind, here's a quick overview of the octal numbering system. If you start with binary numbers, octal is straightforward. The individual positions are each associated with a binary value. The execute permission is associated with 2 to the 0 and has a value of 1. The write permission is associated with 2 to the 1 and has a value of 2. Lastly, the read permission is associated with 2 to the 2 and has a value of 4. If we look at an example for setting both read and write permissions, we get a 4 from the read permission and a 2 from the write permission. Their sum is 6, which is the value that will be used in the chmod command. If instead we wanted to specify read and execute permissions, we sum the read and execute values to get a total of 5. Lastly, if we want all permissions, we sum 4, 2, and 1 to get a total of 7. I do want to mention one quick point. You will often see octal numbers preceded by a 0. This is common and indicates that the number is octal and not decimal. I have omitted it here as the command can use either form, and I didn't want to overcomplicate things. However, using a leading 0 is technically correct, the best kind of correct.
Oh yeah.
Now that you have an idea of how octal works, let's apply it to permissions.
Torrenting.
Instead of changing individual permissions, as in symbolic mode, we specify all the permissions for the file or directory at once. For example, if I want the owner and group to have read-write permissions, and everyone else just to have read permissions, I would use the following command. Remember that read and write are 4 and 2 in octal respectively, and they sum to be 6. Thus, the owner and group permissions have the value 6, and all other users have the permissions value of 4. While octal can be simpler to remember, there are situations where symbolic mode is more useful. They primarily occur when you want to modify some of the special permission attributes. You can read about those in the chmod man page. If you ever need to change the owner and group of a file or directory, the process is straightforward. To change the owner,
can you change the owner of Shadowfile?
Use the chown command.
I chown you.
All we need to do is specify the user and then the file or directory to modify. For example, if I wanted to give ownership of the file hello.txt to Sally, I would use this command.
Bro, I'm crazy enough to do it. Wow. That's the power of Linux.
Notice that I needed root permissions to do that. We could have used the chown command to change the group at the same time if we wanted to. However, we can also use the chgroup command.
Okay. This is like administrating type of stuff. I'm really struggling. I mean, I get why it exists. You have a computer, lots of users. This would be very important. But, I mean, just knowing how to get to admin privileges, root privileges, I mean, that's pretty much, you're good. I wonder if I do this. Okay. Right. These are the password file. It's supposed to be encrypted. Okay, yeah, the hash files are down here.
Here, we change the group ownership of the file to the group Sally. I find that I use these commands primarily
I'm guessing like pin testing, hacking. This is very, very important.
when I extract files from an archive, or have to move
Changing
software from a home
users.
directory to opt so all users have access.
Alright, what was he saying?
However, we can also use the chgroup command. Here, we change the group ownership of the file to the group Sally. I find that I use these commands primarily when I extract files from an archive, or have to move software from a home directory to opt so all users have access.
I mean, that's pretty cool that he used use case scenarios.
As I mentioned in a previous video, some users are able to run commands as another user. This is done with the sudo command, and users capable of using it are specified in the etc groups file. Most commonly, the sudo command is used to execute a command using administrator or root privileges. In this case, we only need to provide the command to execute as an argument to sudo. Let's look at an example. When we were looking at the etc password file, I said that passwords are now stored in a shadow password file. That file is etc shadow.
Probably shouldn't have changed the ownership.
If we look at the long listing of the file, we see that it is owned by root.
Alright, let me change that back. Shadow group.
If we try to access it using a normal account like Bob, we get a permission denied error.
Now he's using cat to read files.
To look at the file, we need to have root level access. To do this, we
Sudo super users do.
use sudo. Notice that it asked for Bob's password to ensure that it was really Bob that is wanting to do this. Once we provide the password,
'Cause he's in the
we
sudo
execute the
group.
cat command as root and then go back to normal permissions.
Let me make sure. I don't remember if I was. Sudo. It's not in alphabetical order. No one's in the shadow group. Was it in the other file? No, because we're looking for group.
For Bob. The sudo command only works for the one command provided. If Bob wants to run a command as Sally, he would specify you and her username. For example, Bob can't read the sample.txt file in Sally's home directory. As you can see, only Sally has permission to read the file. To read it, Bob will need to run the cat command using Sally's permissions, like this.
Sudo user Sally.
Remember that only that one command was executed as Sally. Once it is finished, Bob reverts back to his normal permissions. If we wanted to change to a different user for multiple commands,
Okay. What is that? What is that? Switch has to be switch.
we could use the su command.
Here goes
Let's
Jimro.
see an example where we change to be Sally.
Switch user. Yeah.
As you can see from the prompt, we are now acting as Sally on the system. Be careful using this command, especially as root, since you can forget which user you are currently acting as in the system. While this course isn't focused on administrating Linux, there is one important point to be made. It is a best practice to perform your normal day-to-day activities as a normal user and only elevate your privileges to root using sudo when needed. It provides better security and can prevent mistakes from becoming big problems. Focused on administrating Linux, there is one important point to be made. It is a best practice to perform your normal day-to-day activities as a normal user and only elevate your privileges to root using sudo when needed. It provides better security and can prevent mistakes from becoming big problems.
Wait, what did he say?
As I mentioned, activities as a normal user and only elevate your privileges to root using sudo when needed. While we won't cover much
Alright, last video of this section, and then I guess we're installing software.
much about administering users in Linux, I do want to briefly discuss how to change a user's password. We will use the password command to do this. Notice in the man page that the login is optional and that the description states that normal users can only change their own password. Let's try changing Bob's password. The command prompts us for our current password to authenticate that someone else isn't trying to change our password. I'll enter the wrong password to demonstrate what happens. As you can see, it generates an error. Let's try again and enter the correct password this time. After we correctly enter our current password, we enter our new password. We then have to retype the new password to confirm it. After we retype the password, the utility will verify that the new password passes all the required rules, such as password age and complexity. In this case, it did not. I'll enter one that does. Now that it passed those tests, the password was changed. If you want to change another user's password, you need to temporarily elevate your permissions to an administrator and then provide the user's name after the password command.
So sudo passwd Sally, that girl.
Notice in this process, I only had to enter Bob's password and not Sally's password. Also, you can't see it here, but the validity of Sally's new password wasn't tested. Since we are using admin permissions, the system simply changed the user's password to whatever we specified. You probably won't need to change passwords often, but it is important to know how to do it.
Because Bob's in the sudoers file. Alright, my main objective was to get over that little area. We can start another video because it is not quite midnight yet. I want to keep on going until midnight. Let me just check something real quick. Okay. Linux package management.
Modern Linux distributions primarily use a centralized system that automates installing, updating, configuring, and uninstalling software. These package management systems accomplish this by storing a program's executable, libraries, and configuration into a single archive called a package. They are very similar to Apple's App Store or Google Play, with a few exceptions. First, there is no verification process for software. Second, there is no one standard for packages in Linux. There are a number of different systems accomplish this by storing a program's executable, libraries, and configuration distributions.
It's amazing to me how much I will
primarily use a centralized system that automates installing, updating, configuring, and uninstalling software. These package management systems accomplish this by storing a program's executable, libraries, and configuration into a single archive called a package. They are very similar to Apple's App Store or Google Play, with a few exceptions. First, there is no verification process for software. Second, there is no one standard for packages in Linux. There are a number of different formats, but the two prevalent standards are DEB for Debian-based distributions and RPM for Red Hat-based distributions.
Yum.
Before package managers, Linux users had to download a program from the internet and manually install and configure it. Some programs even had to be compiled from source code before installation. With package management systems, all the user has to do is ask to install the software. The program on the screen is a GUI front end to the package management system in Linux Mint. It looks and acts similar to a normal app store. I can search for a program and view information and even install it. If I were to click on this button to install the software, the package management system would search a repository of all the available software for the package I want to install. When it found the appropriate package, it would automatically download it and install it on my system, and then configure it. This all would happen in the background, so I don't need to know any of the details. One of the most significant benefits of a package management system is that programs frequently depend on third-party libraries. These dependencies can be difficult to manage manually, especially when the dependency is to a specific version of the library. Fortunately, current package management systems handle all of these dependencies for you. Linux Mint also has a GUI package manager called Synaptic, which is shown here, that provides a lower-level view of the software. When we indicate that I want to install this software, we see that Synaptic notifies us about all of these dependencies. In the next few videos, we will see how to do this from the command line. The benefit of using the command line is that it can be used when we do not have access to a window manager, such as when we have a remote login. Indicate that Linux Mint also has a GUI package manager called Synaptic, which is shown. here that provides a lower level view of the software. When we indicate that I want to install this software, we see
Okay, dependencies, okay.
as mentioned in the previous video, Debian-based distributions use deb packages to simplify installing, updating, configuring, and uninstalling software. There are two package management programs that are primarily used when working with deb files. The first is a low-level tool called dpackage. However, since dpackage can't automatically download packages from a repository, the second program apt is more commonly used. As a result, we're going to focus on apt for this video. Let's see a few examples. Before we install or update any software, we need to ensure that our system has the most up-to-date information on the available software packages and their versions. To update this information, we run the command apt update. Notice that it asks for my password since it needs to run with elevated privileges. With the updated information, we can see if any of the software that is already installed on our system can be updated using this command apt list --upgradable. If we want to upgrade these packages without installing it asks for my password since it needs to run with elevated. As a result, we're going to focus on apt for this video. Let's see a few examples. Before we install or update any software, we need to ensure that our system has the most up-to-date information on the available software packages and their versions. To update this information, we run the command apt update. Notice that it asks for my password since it needs to run with elevated privileges. With the updated information, we can see if any of the software that is already installed on our system can be
2,000 packages can be upgraded. Wow.
Updated using this command apt list --upgradable. If we want to upgrade these packages without installing any other software, we can run the command apt upgrade. It will prompt me to confirm downloading, in this case, 404 megabytes of additional disk space.
Fuck it, I'll do it too. Okay, somebody walks on you and your computer's doing this, they're gonna be thinking that you're Mr. Hacker Man.
Frequently, you'll find that it can download the files quicker than the installation process itself. Apparently, there were some rather large updates to my system, primarily the main one being a new kernel. However, now our system is up to date. Sometimes new versions of software need extra packages or no longer need some old ones. If we wanted to take care of those items at the same time, we could have specified a full upgrade, but the normal upgrade is fine for now. It's important to note that not only are user programs, such as a web browser or text editor, updated using this process, but updates to the operating system itself, as you just saw, also use this mechanism. Now, let's use apt to install some software. I frequently use a command line tool for manipulating PDF files called PDFTK. It is very useful, but often isn't installed by default. We can check to see if it's installed by using the which command. Nothing was returned, so it's not installed in the system. Let's search to see if we can find it in the package management system using the command apt search pdftk. As you can see, there are two packages that match.
Still going.
Even if your search string is very specific, you will often have more than one search result. Sometimes you might need to do a little research to determine which package you want. Since the default PDFTK package is marked as transitional, it may mean that the developers are moving away from this package to a newer one. We can check the information about the package using the command apt show pdftk.
Oh.
Reading the description,
Maybe Fedora uses.
we see that since newer versions of the PDFTK package aren't in Debian anymore, the maintainers of the package suggest moving to the Java port we saw previously listed. Now that we know which package we want to install, we can use the command apt install pdftk-java. Since installing requires root privileges, we need to enter the password.
That you can also use autocomplete on the packages, which seems crazy to me. I guess your computer knows all the packages names
To temporarily get those permissions. Remember, this only works if the user is a member of the admin group. The package management system checked the repository to determine everything that needed to be installed. We can see that a number of new packages will be installed, and it will require almost 6 megabytes of storage. Once I acknowledge that I want to install the software, the package management system downloads the packages and installs them on the system. That is all you have to do. We can verify that it was installed using the which command.
over a year ago, and I haven't touched it. So
It now finds
it's
the binary
updated a
executable.
lot.
That means it's installed on the system. If we ever want to remove the software from the system, we have two options. If we just wanted to uninstall it, we could use the command apt remove pdftk java.
If you want to nuke it off the face
Just
of
like
the
when we
earth,
installed it, apt prompted for confirmation before actually removing the software. Note that the dependencies that were installed along with the software are not uninstalled by default. They may be required by other packages, so the system is trying to be careful. Once the process finishes, the software is uninstalled. Some packages use configuration files that aren't always cleaned up by simply uninstalling the software. If we want to remove those as well, we could use the command apt purge pdftk java by simply uninstalling the software. If we want to remove those as well, we could use the Some packages use configuration files that aren't always cleaned up by simply uninstalling the software.
yeah, because sometimes
If
you
we want to
customize
remove
them.
those as well, we could use the command apt purge pdftk java. Since we already removed the package, the command won't succeed. It does note, however, that we still need to uninstall the leftover dependencies. Let's do that now with the command apt auto remove. Since we already removed the package, the command won't succeed. It does note, however, that we still need to uninstall the leftover dependencies. Let's do that now with the command apt auto remove. We have uninstalled everything and are back to the original system before we installed PDFTK. There's a lot more to managing deb packages on your system, but the content covered in this video is all you need to know for the vast majority of the time.
Okay, what?
Purge PDFTK Java. Since we already removed the package, the command won't succeed. It does note, however, that we still need to uninstall the leftover dependencies. Let's do that now with the command apt
Sudo
auto
apt
remove.
We didn't even give this command. Okay, these.
We have uninstalled everything and are back to the original system
So
before we
uninstall it,
installed
it usually leaves something
PDFTK.
behind.
There's a lot more to managing deb packages on your system, but the content covered in this video is all you need to know for the vast majority of the time.
Okay, well, let's try one. Okay, you're gonna like this one. This is a really good way to end. Okay. I remember there was like all kinds of. Well, let me not give it away. Damn it. What is toilet? Is that another package? Alright, it's kind of formatted horribly, but you get the gist. Um, I used to have it when you would open your terminal. It would display like a random ASCII, and it was really cool. I had it really customized, and I might still have it on one of my systems. I've had so many Linux builds break on me randomly because I was always tinkering and learning, and I think that's it for today. What was the next video? Package management, Red Hat. Okay, we'll watch this. I don't have a Red Hat system. That's like Fedora, CentOS. We'll watch it. There's nothing really much to do.
As with Debian-based systems, systems that use RPM files for package management have two tools for managing software. The low-level tool is called simply RPM, and the high-level tool is Yum. Since Yum is similar to apt in functionality and ease of use, we will focus on that in this video. As with apt, we can ensure that our system has the most up-to-date information on the available software packages and their versions. We can use the following command to update this information: sudo yum check-update. We have one file to update. However, it isn't necessary to run this command, as it is automatically run before the system updates the software, unlike apt. The update command in Yum is essentially a combination of the update and upgrade commands we used in apt. I can confirm the installation. As with apt, it did everything in the background from downloading the software from the repository, installing it, and configuring it. For various reasons, the PDFTK utility we installed in Linux Mint isn't available using the package management system in CentOS, the virtual machine I have here. However, there is an alternative called QPDF. We can search for it using the following command: yum search QPDF.
Okay, when I first started learning all this stuff, it was so alien to me. Yum.
As in Linux Mint, the search yielded multiple results. The first one listed is probably the one we want, but we can get more information, so we are sure it is the correct one. To get more information, we use the command yum info qpdf. From the description, it looks like this is the package we want. To install it, we use the command sudo yum install qpdf. Remember, since we are installing software, we need to temporarily get root privileges, so we use sudo. Once we confirm the prompt, the software is installed. We can verify it was installed using the which command.
Yeah, a lot of the commands.
It was able to find the binary executable, so it's installed. If we ever want to remove the software from the system, we can use the following command: sudo yum remove qpdf. The system asks for confirmation before deleting it, just like when we installed it. Unlike apt, Yum doesn't provide a command to completely purge all configuration files from the system. As with Debian-based systems, there is more to managing software packages.
So you just have residual files
In an RPM-based distribution. Apt, Yum doesn't provide a command to completely purge all configuration files from the system. As with Debian-based systems, there is more to managing software packages in an RPM-based distributions like CentOS. But the content covered in this video is all you need to know the vast majority.
Oh, I say CentOS. He says CentOS. Alright, what has that been? Hour and 12 minutes. Okay. I am over 50% complete. Oh, congratulations. Pipes. I just showed you how to use pipes in case you were wondering. That was the bar. It's called pipes. Instinct just tells me to call them bars. And I'll be shutting down. Hour's good.